Thanks, Mr. Chair. And I want to thank the panel and all your colleagues for your persistence and your perseverance with this project, because it had a few ups and downs over the course of its life. And I want to thank this committee for its patience, because the scientific products that have come from this are just remarkable. So, Dr. Battaglia, I want to start with you. How do you choose what exoplanets you're going to study? I mean, you said there's a whole bunch of them, but you picked 70. And then I'm going to talk to you, Dr. Finkelstein. How do you choose what galaxies you want to look at?
Great question. There are over 5,000 exoplanets that we know of, but not all of them are bright enough for us to study their atmospheres, even with Webb. So there is a NASA mission called TESS, which is doing an all-sky survey to find transiting exoplanets that are near the solar system. Those are the ones for which we can get really good precision, part per million precision, to see these bumps and wiggles in the spectrum that are telling us about the presence of molecules. So the list gets whittled down. There are still hundreds, even after that, many hundreds. And so you look at this kind of science questions that you want to answer. There is an exoplanet, or a star called TRAPPIST-1 that is very close to us, that harbors 7 exoplanets orbiting it, 3 of which are in the habitable zone, orbit in the habitable zone. So you can imagine that we are spending a good deal of time observing those planets. That's going to be a high priority target.
So how do you and your colleagues choose who's going to study what planet? How do you share information among all of this? I mean, how is it open? Is it closed? Is it, I got planet X, you got planet Y, we don't talk to each other?
Yeah, it's a little of both. For the early release science program back in 2016, I started an open committee. It was open to everybody who wanted to participate. We have over 300 scientists who participated in that process in order to create a truly grassroots strategic plan for what the very first exoplanets we would observe should be. So that was an open process. The data is non-proprietary. Anybody who wants to participate can. It's truly open science, and that's been a very valuable exercise for how we do science.
Great. Dr. Finkelstein.
Yeah, thank you. So first, I also want to acknowledge the large number of people that made this possible, including the Sears team. Not quite 300. We have about 200 scientists in our team, and of course the engineers that made this telescope possible, and the people doing the work, which is usually the junior scientists, the graduate students and postdocs. So how did we decide what galaxies to see? Well, we didn't know these galaxies. We're discovering them. So we are doing what we call blank field astronomy, which was a wild idea first tested out in the mid-1990s with the Hubble Deep Field. The Hubble Deep Field was kind of a bold idea to point at what we thought was an empty place in the sky, spend a couple hundred hours observing and see what you find. And I think many people thought you would find nothing, and it turns out you see the universe is filled with galaxies. And that's become a very useful strategy now. We know that there are galaxies pretty much no matter where you look. So then the next question is, why did we look at this particular place in the sky known as the extended growth strip? And the reason why is that Hubble had looked there before. And the Hubble data is very, very useful for the JWST data. Hubble has the visible wavelength data that's just crucial to combine with our infrared data. And finally, one key part of our early release science program in particular is we're using multiple instruments with JWST, and we want them all to overlap the same place on the sky. And it turns out with a sort of fate of geometry, this extended growth strip field is kind of a strip in the sky, and JWST can look at that strip at just the right angle to allow the instruments to overlap. So it's a nice combination of things that allow us to point here.
Thank you. And Dr. Champlin, last question. As you built the telescope, and there were a few hiccups along the way, what would you do differently today if you were going to build another telescope like this?
So I can spend hours talking about this, but I helped chair a NASA study called the Large Mission Study, and I was the person who put together the plans for how we would formulate the next mission differently. So the first and most important one, I think, is you need to focus on schedule from the beginning. You also need to get the technologies to fully matured before you start actually designing the mission. And I don't just mean 6 or 7 individual miracles. You have to remember that those miracles have to work together. So the biggest challenge on these very large missions is the system, not the individual technologies. So think about that and make sure you don't overdo the science requirements and you keep focus on the key science that you want to do. And I think that's the path to success.
All right, thank you. I yield back to the chair. Thank you.